Welcome back. We are now going to elaborate on the topic of software-defined vehicles. We are very happy to welcome in person Ralf Lenninger. He is the Vice President of Vehicle Networking and Information, Strategy and Future Solutions at Continental. So I understand Continental is a tire company. So what exactly does it have to do with software? That's something you're about to explain to us.
Yeah, Lara, this is a really good example of what really happens in the automotive industry. 150 years ago, a company was founded to produce tires. Now, suddenly this company, 200,000 people plus around the globe, have more than 10,000 software people. What happened? The automotive industry always looked around, and whenever new technologies was available, the new technologies was used in even to make the car better. Sudden electronic comes in, mechanical systems get a backpack on electronics, systems got better. Software kicks in, and additional to the electronics, the software kicks in, and the systems and the car gets better and better. And better means more safe, more efficient, and more comfort for the people. Give you an example, introduction on electronic brake systems, which have significantly reduced fatalities and deaths in traffic. Give you the example by using electronics and software in the engine management arena, which significantly reduce emissions, naming airbags and a lot of other examples in the car. And that leads to the situation that nowadays the tire manufacturer out of Hanover with 10,000 people plus is doing more than 50% on their revenues with electronic products, software-defined products around the globe with all car manufacturers.
Before you get started, I just want to remind our viewers that you can send your questions to Ralf on our website, and we will then answer them after in a Q&A. So without further ado, Ralf, I'll let you take it away.
Fantastic, Lara. Thanks very much. Yeah, situation is very clear. We are in a significant transformation. So the demands on the consumers for mobility for a car become significantly different. Self-driving, no fatalities, clean cars, highly comfortable, connected into the complete internet world. Of course, car manufacturers need to adapt to the consumers' demands and needs to offer the respective cars, including the necessary adaptations around the globe following the legal advices. We as a supplier, of course, also need to make a significant transformation in order to make those demands happen. And what is significantly kicking in is regulations around the globe. And CO2 is only one example. Good sentence on that is, in the past, the car have changed the world. Now the world is changing the car with all these new demands. So what is now happening? So you may read out of the press, software in the car, a lot of problems, a lot of challenges. On the other side, new functions are coming in. And what in the automotive industry now is taking place, the same transformation as took place when you have had a mobile phone to the smartphone. In former times, for every function, you have an own electronic devices, before the smartphone, same in the car. So up to now, more than 100 complex, high-performing electronics in the car integrated. And now, due to the networking on those one, and those complexity, a significant step needs to be done, a real revolution by integrating separate functions into so-called HPCS, high-performance controllers. That is the migration which is now up and running. And based on that, like the smartphone or new generations, these migration will go on. So look for some numbers. If you compare a smartphone with a car, in a smartphone you have one microprocessor, you have one display, you have one operating system, 7 sensors, 170-40 grams, and speed is 0. If you look to the car, 100 microcontrollers are working on that, 4 displays, 4 different operating systems. You have hundreds of sensors and actuators in the car, and of course the car is running high speed up to 250 kilometers. And the very important thing is the electronic in the car needs to be always safe. A hang and a reset in a software, in a brake software, would be not a good idea in order to take care on safe driving of the people. So with all the challenges, the complexity, with the quality demands, 10 years lifetime on that, so we have started in the industry to make all these software functions happen. Give you a number, more than 500,000 software engineers around the globe are working on the new digitalized cars. Give you one example for that. You may know the ID.3, ID.4 car from Volkswagen. So what we have designed is the so-called central brain, called ICAS, electronic for the car. And for this one device in the car, this HPC, this is communicating in real time with high safety requirements with 68 other electronics in the car. Keeping in mind, in the car, you have approximately more than 30,000 different protocols, where the electronics are just communicating together. So if you do such a device, an important point is now kicking in, you cannot do it anymore as one company alone. So 19 different companies are contributing software packages in order to make this device happen. To describe such an electronic products, we have more than 70,000 stakeholder requirements. 70,000, which needs to make sure in a perfect manner that they are realized in the products. 2.1 million development hours in software, and more than 600 software people are just working on this only project. And that may give you an attitude and an impression on the complexity which is going on. And it's not enough for that, because the connected car means a connected car. It's not enough to make the network in the car happen in order to fulfill the demands of the consumers and of the driver of the car. The complete network in the car needs to be interconnected to the complete back-end world. And in order to that, respective architecture was set up, and the first functions are brought in and up and running. And it's really fantastic functions. Give you an example. If you look for the e-call, the e-call is in case of an accident, the car automatically sends the information on positioning and asks for help to the urgencies. This is up and running. And in order to make those systems happen, as one company in one domain, it's not alone. You need cooperations, you need access to technologies, and this is then one of the major challenges and requirements in the industry in order to make that happen. Give you one example, what we are doing with Continental. We have a lot of technologies partners. Give you one example, which is SUSE or QNX. We have things like AutoSAR helping us in for ADAS. We have Sensorics and a lot of other partners in that. And of course, very intensive relationships and cooperations with the semiconductor supplier, because the semiconductor and our development needs to go very much hand in hand. On the other side, if you are looking for the back end, even on that, we need this kind of partnerships to make all this integration happen with the functionalities in the car, with the demands and the requirements on the back end for new mobility services, but also for other services coming from Amazon or Google, and you name it. So clear is, challenge is huge. It's blood, sweat and tears to make it happen, but it's the only way to bring the car into the demands of the society, new requirements, the safe car, no fatality, and a clean car, and also a connected car that the consumer can enjoy riding with a car on that. So clear as Continental, so we see more a chance in this transformation than a risk. As we said before, those challenges always have been the lifeblood of Continental, from a tire to a software company. So we are proud with all our people that we are first in the market on that. Challenging is how to monetize all the effort. And to give you one indication, our R&D investment is more than 10% on our overall sales. And that's a huge number. And so we need to find even better ways to monetize our contributions to the products in the car and also to new kind of mobility solutions on that. Competence and technology is the value which we are bringing in, and said before, we have more than 40,000 developers around the globe for the various technologies, and more than 10,000 out of that are software people, and going to enrich that with the cooperation on the software companies, as mentioned before. This is the thing where we think we create value, we can contribute to the better and to the modern car. And the last thing is the synergies, as said before, to make it via cooperation in vertical and horizontal happen. So with that, for the complete mobility industry, yes, we are doing the utmost in order to prepare a car in such a manner that the car is prepared for new mobility services, keeping in mind safety goes first, and it's not only safety of the car, it's also the privacy and the security and data on that. And so we are pleased to have ASEA, for example, or other platforms in order to help us in the automotive industry, but also with companies outside of the auto industry to make standards in order to make interfaces happen. With the target is to have zero emissions, zero death, zero fatalities, and a great user experience by having a connected car. So with that, Laura, thank you very much for the time. It was a pleasure.
So we do have some questions that came in for you. This is a topic that's been brought up several times now in the past few days. And the question is, how much does the chip shortage affect the software-defined vehicle?
Yeah, so in a first sense, the chip shortage is significantly influencing the production, the production of the car manufacturer. We are not sure if this is solved in short term. Now, talking to our semiconductor suppliers, so the indication is that it will go on in 22 as well. Question is what happened? And at least it's two effects. The first effect we mentioned, it's COVID. Stop and go on a semiconductor plants is one effect, but the other effect is the demand planning. So the whole world is talking on digitalization. If you go for governmental, if you go to your private life, so all are going for digitalization, and for digitalization you need hardware. You need chips. And that is clear that the demand now coming with digitalization is much, much more than the installed capacity on the semiconductor suppliers. And now these effects are coming together. A strong market growth in demands due to digitalization, plus a stop and go due to COVID.
Yeah.
And that brought us in the difficult situation. We get a lot of support on the semiconductor guys. We get a lot of support also from the car manufacturer, but the situation is critical. You know the number of plants from the car manufacturer which have a standstill, and same on our side.
Thank you for that. So the next question is about tires, and it says, does tire composition need to change for the torque from electric vehicles?
Yes. Yeah, of course, and we set up an own development line for electric car tires. By the way, it's not only the torque, other challenges are coming in. As more frictions you have, as more energy consumption it is. So we created an own product line for tires for electric cars.
Okay. So I think we have time for at least two more questions. It says here, more and more OEMs are focusing on self-developing auto-related software and OS. How can major tiers like Continental help OEMs' initiative on software development?
Yeah, that's a good question. So one car manufacturer answers this question to me. They are saying, see, in the past, our engine, that was the unique selling proposition of the car. As better the engine is, as better you can sell the car. And what was as a unique selling proposition, the engine in the past, is now software. And as the car manufacturer have developed their own engines, they need to develop this part of the software which can create unique selling propositions. But that doesn't mean that they have in mind to develop all software. Give an example. If you take an airbag electronic, whatever software you have in an airbag electronic, you cannot generate so much unique selling points. So I could not imagine that I buy a car because of a different software on airbag electronic. And so you will have two worlds. One software world, which is driving the unique selling proposition on the car manufacturer, and this is what they would like to control. And the other world, where the car manufacturer is saying, this is not something USP, I would like to participate from the economy of scale at the supplier base. And I personally feel good with that.
Okay. One last question about the chip shortage again. The question is, will the current chip supply crisis affect prices in the long run?
Yeah, if you go to the press, some car manufacturers have made statements that they need to increase their car prices due to the material. Keeping in mind, it's not only chip shortage. If you go to all material, if it is wood, if it is steel, if it is plastic, so in all material we have a significant price increase. So one number comes from an US consulting company, cannot comment on that, can only give you the number, and they have found out that the material cost for a car in US nowadays is $1,400 more than 12 months ago. Okay, that's quite a lot. Where the minority of this is coming from semiconductor. More is coming from steel, and if you look for the London raw material exchange, as you can see what is happening with all raw material. It's fluctuation, but if we see the indication from the analysts, so all material may not in the long term go down to the level as it has been years ago. Okay. All right, Ralf Lenninger from Continental, I thank you very much for your time and for your presentation. Okay, Lara, it was a pleasure with you. Thank you guys for your time and have a great day. Thanks. So we are going to take a very short break, but when we come back, we're going to hear about the great shift in Taiwan and more about Arvato's financial solutions for Lynk & Co. I'll see you in a few.